Today we start right triangles in the Pythagorean theorem, and to get started, you should recall from many of your math classes prior to this the Pythagorean theorem. So this, you may not know it by name, but it is the very well-known a squared plus b squared is equal to c squared, where you can find the length of any side of any right triangle given that the right triangle has side lengths A, B, and C, where C is your hypotenuse, and your hypotenuse is always opposite your right angle, and it is always your longest side. And A and B are arbitrary. More times than not, people assign that A is less than B, but there's nothing that says that B can't be less than A. In addition to the Pythagorean theorem, we also can identify whether or not a triangle is acute, right, or obtuse based on its side lengths. So still keeping C as our longest side, if C squared is equal to A squared plus B squared, then we know that it's a right triangle. If C squared is less than A squared plus B squared, then it is an acute triangle. And if C squared is greater than A squared plus B squared, then we know that it is an obtuse triangle. You should have also studied special right triangles at some point throughout your math studies leading up to this point in high school. And just to give you a very brief refresher on what those special right triangles are, you have two different kinds. You have the isosceles right triangle, which gives you a 45-45-90 ratio with your angles. So I have 45 degrees and 45 degrees, and it makes it an isosceles right triangle. And what we know about this right triangle is if our two side lengths are congruent to one another, then that means their hypotenuse is going to be the side length times the square root of 2. And then in addition to that, we have the 30-60-90 right triangle, where this angle is 30 and this angle is 60. And what we know about it is the side opposite the 30-degree angle is what we refer to as the short leg. And the side opposite the 60-degree angle is what we know as the long leg. Well, if we call the short leg S, then we know that the hypotenuse is going to be twice the length of S. And we know that the long leg is going to be S times the square root of 3. Okay, and tomorrow we will get into the trigonometric ratios of right triangles, but one last refresher is the distance formula that goes hand in hand with the Pythagorean theorem of finding the distance between 2 points in the plane. So with your distance formula, we know that d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, where x1, y1, and x2, y2 identify two different points in the coordinate plane.